Section 11.6, integration by parts. So this is a method of integrating some of the products of two functions that you could be asked to integrate. So first of all, where does the idea of integration by parts come from? This is just using the rearranged form of the product rule. And then undoing it, so integrating the product rule, but we are going to rearrange it. So over here, if you can quote the product rule, so uv dash is equal to vu dash plus uv dash. That's how we learn in Haybridge, this rule. So imagine at this particular instance, we want to undo that differentiation. So we are going to integrate it. So if you integrate uv dash, you'll come back to uv. Now over here, we just need to integrate vu dash and then integrate uv dash. There you go. And what we are going to do right now, we are going to rearrange it. So we are going to leave the integral of uv dash on the left-hand side. And then we are going to write it as move this one onto that side, so you have uv minus the integral of vu dash. And this is a very shorthand way of writing the integration by parts. In the formula booklet, it says more, the v is written, the v dash is written as dv dx, so it's a more formal one. And then you've got u times v minus the integral of v du dx dx. So whenever you're going to use this method, you need to quote it. You can quote it that way. That's perfectly fine. So it simply comes from differentiating a product and then rearranging it. So effectively, when you have a product of two functions, you are going to think of one function as u and one with, think of it as differentiated v, and then by working out what v and u dash are, you can collect them together in this combination and then integrate the integral on the right hand side, and it works beautifully. Okay, so let's have a go at example in the book, the first example, which is example 16. So I will go through some detailed rules in a minute as well. So you've got two functions. There's a product of two of them. You've got x, which is multiplied by trig function. Whenever x or x squared or 2x or 2x squared, a multiple of these, is multiplied by another function, you will set that always as u, unless it's multiplied by ln. Okay, so always set u equals to that, unless it's multiplied by ln x, as we have in the example 17. So you're going to set it out the same way you set out u underneath the u dash and then v underneath the v dash, the same way as in the product quotient rule. So the bits we're going to fill in, this is your u and this is your v dash. And now the left hand side goes down, you differentiate. The right hand side goes up, you integrate, it's increase. So think integrate, sorry, it for increase, and differentiate for going down. Okay, so that goes to 1, and cos x integrates to sine x. Remember to integrate. So then we've got to think about the by parts rule, but really, if you remember the next step by pattern, it's absolutely fine. So think about number 7. Okay, so you are going to do u times v minus the integral of u dash v. Okay, so this is our integral. So this time together gives me x times sine x, so number 7 minus these two times together, which is 1 times sine x, which is sine x. Straight away you could write it down. So it's x sine x, and then we need to integrate sine x. Sine integrates to minus cos. So just write it finally by simplifying those two minuses to a plus. Done. Okay, the second example, here we've got again x squared times another function. If this function was e, if the function was trig function, then you set x squared as u. However, if it's not, you've got to set your u as ln x. There you go. So x squared has no choice but to be v dash. So we differentiate this side, which is 1 over x, and we integrate this side, which is add 1 to the power, divide by that power, so x cubed over 3. And then we do number 7. So it's my integral is going to be ln x times x cubed. Let's put the times symbol in, so because in a minute we're going to put that in front, minus 1 over x times x cubed over 3. So this one becomes, let's put 1/3 x cubed ln x. Ln x looks better at the back. And this one, we've got to do the integral of 1/3 of x to the power of 2. So it's 1/3 of x to the power of 2. And so that's add 1 to the power, divide by that power. So it's minus 1/3 already here, and then another third because we'll be dividing by 3, x to the power of 3. Okay, so you could leave your answer like this, that's perfectly fine. For those of you who like things to be tidier, you could potentially take out 1/9. Okay, so create that into a 9th, and then x cubed. So you'll be left with 3 ln x minus 1. But don't worry if you don't get it at this stage. You just need to, you could have just given the answer on the previous line. Okay, so we'll move on to example 18. So this time we've got x squared multiplied by e to the power of x. Okay, so again, product of two functions. We're going to set x squared as u and v dash as e to the power of x. Differentiate going down, so that goes to 2x. Integrate, going increase the power, e to the power of x stays the same. So we are going to do number 7. So it's going to be that times that, so it's x squared times e to the power of x minus the integral of 2x times e to the power of x. So that's our integral. Let's call it integral 1. Okay, the reason I've called it integral 1, because actually I still cannot integrate this part. So I need to do by parts again. So we're going to set u as 2x. So u dash is 2. We're going to set v dash as e to the power of x. So v is equal to e to the power of x, and another number 7. So let's call it I2. So it's going to be 2x multiplied by ex minus the integral of 2ex dx. So it's 2x e to the power of x minus 2e to the power of x. So overall, we're looking for this integral. I called it I1. So it's x squared e to the power of x, excuse me, minus, and then this here is our I2. So I need to surround it with brackets so I don't make any mistakes with negatives. Expand it, and you could factorize e perhaps, or leave it as it is. I'll factorize e's just so you can see what it looks like. So e to the power of x, and you've got x squared minus 2x plus 2 in bracket, and don't forget plus c at the end. Perfect. Okay, now this is a very, very important example. Really, really crucial. If you remember from before, you did not, when you did differentiation, you can differentiate ln x, but integrating ln x is not something that you know about, so you need to learn how to do it. So you always do by parts. And the rule is, whenever there is ln x in any question that you are going to do by parts, you will set your u as ln x. But where is the product? Well, you might say there's on a single function, but that function is ln x times 1. So you're going to set v dash as 1. So v will be integrating, so 1 integrates to x, add 1 to the power, divide by the power, and ln x differentiates to 1 over x. So number 7, so our integral is going to be ln x times x minus the integral of 1 over x times x. So this x looks better at the front, so it's x ln x. Otherwise it looks like ln x squared, which is totally wrong. These nicely cancel, so you've got the integral of 1. So it's x ln x minus x plus c if you didn't have the limits. We have the limits of 1 and 2. So put 2 in, 2 times ln 2 minus 2. And then 1 times ln 1 minus 1. So this is going to be 2 ln 2 minus 2. Take away. 1 ln 1 is 0 because ln 1 is 0. So it's minus 1. So it's minus 2 plus 1, which is minus 1. There you go. So now you can have a go at